At different times in this unit, we're going to have on worksheets problems that refer to a modified Atwood machine. So we just want to show you what that is. The idea is that you have one mass and it's being pulled by a second mass by way of a pulley. All right, and it's accelerating downward. Okay. So this mass is probably larger, say, than this mass, okay? And to make things a little simpler, we're going to say that we have a frictionless surface, and we're going to call down the positive direction, okay? So it's accelerating down. All right, so let's look at some force diagrams for mass 1 and mass 2 and see what all this looks like. So, again, we've got mass 1 and mass 2. Okay, they're accelerating in the downward direction, mass 2 is. So if we go to draw a force diagram for mass 1, right, we've got a normal force, okay? And we've got an equal and opposite force of gravity. And we also have a force of tension. Okay, so there's some tension along this string right here. All right, so F net for mass 1 is to the right. We'll pick a better color. And it's equal to that force of tension. Okay, so remember, F net, we're saying equals that force of tension. And we've learned now that F net equals MA. And we're talking about mass 1. So mass 1 times the acceleration. Okay. Now the acceleration of box 1 and box 2, mass 1 and mass 2, are obviously going to be the same. So now if we look at box 2, we've got a bigger force of gravity. So I'll make this a little longer. Okay. And this force of tension is the same as it was above. Okay. These two forces of tension are equal. They're identical. It's the same string. Okay? Can't have a different force of tension on part of the string than you do on a different part of the string. So for this, again, we'll switch to a better color. We're going to say that F net is got a net force going down. Okay? And that's going to be equal to the force of gravity. Remember, we're calling down positive, minus the force of tension. And this is going to equal MA, but we're talking about mass 2 now. So M2A. And what we're going to do is a little bit of substituting and see if we can come up with an equation. Substituting, let's just see if I can spell there. Okay, so we know that FT equals M1A. So is it okay if I just plug in M1A for FT? All right. And we also know that the force of gravity, okay, here for mass 2 is mass 2 times G. So what I've got now is M2G minus M1A equals M2A. So we've accounted for mass 1 and mass 2. Remember, these accelerations are the same, and that's just your acceleration due to gravity. Okay, what I'm going to do is rearrange here just to make things a little bit more interesting. Okay, so M2G, I'm going to take this piece and move it to the other side. Okay, so I have M1A plus M2A. And I can set that equal to M1 plus M2 times A, right? All I did was pull these out, and that's equal to M2G. What I'm trying to do is get an equation for acceleration here. So A equals M2G divided by M1 plus M2. Okay? So what this is telling us is the weight, okay, the weight of mass 2 is providing the net force to accelerate what? Well, to accelerate both m1 and m2. Okay, that total mass. So on this pulley, this mass provides all of the net force needed to accelerate both this mass and this mass. And that's a modified Atwood machine, and you'll see that in some problems.